Hey guys, just showing my updated meteorite effect. This one here looks pretty good, doesn't it? So from all angles it's got an animated tail now, so that's a lot better. And from the front of it, it still looks good. Yeah. So can't see any issues with the X configuration of my, really, any serious problems there. Yeah, so from all angles it looks good. So that's why I don't use a billboard for meteorites, because I need it to look differently from different angles. I don't want the billboard always facing the camera looking the same from all directions. That's no good. Yeah, so that's the updated meteorite, and it's using my updated API for texture cropping. So this is the method that we've all been waiting for, including myself actually, where you get a single sprite sheet and you tell a simple API to split it up into parts and just show it and have it all done simply and easily, and done in C++, because it's much quicker if it's coded in C++ than in JavaScript. One where you can just put the node in and some basic information, and then using that you can iterate over hundreds of different like meteorite effects or any other nodes you want really quickly, really easily. Existing methods, you've got Nico's method still in the system by default. You're just swapping out little tiny textures, which you have to take a sprite sheet like this, typically how it comes, and then you have to cut it up into little pieces, and then you have to reattach it manually in the system, which is a real pain actually. You know, you might have 20, 30, 50 little images. You have to all attach back correctly in the right order, and then it'll iterate over each of those, from the start to the end. And it works fast, but it is a pain. It's a real pain. So this is a much better method. And the only code you need to put is just something like this. Simple line API, set texture crop. So I've got image cropping, 2D overlay image cropping. Now we've got texture cropping as well. You just put the node, you put the material, which is typically 0. You put how many across, and then how many down. So it's how many columns and then rows, so 7 by 4. Then you put the variable you're starting at. You don't have to start from the start. You can start at any number. That's the good thing about this one. It's extremely versatile. It'll pick up any number from the start to the end. So it's 47 to 28 textures in total. You can start from 1, or you can start halfway if you want. So in other words, I can individually manage the animation of my meteorite effect, each meteorite effect separately and differently. So they're all different. They all start at a different point, which would be better than having them all look the same, which is, if you use Nico's method, they all look the same. They're all basically using the same copies, the same time. They're all just copies of each other, exact copies of each other. But this way you can have a lot more versatility and manage each one separately. Put true for looping, false for just start and stop at the end. And it won't run any more code after that. So it's extremely simple. Okay, so this is Nico's method, animate node under C+ animator, animate textures. You're just getting a few checks, getting the time, changing the index over time from the start to the end, and depending on whether you want to loop or you don't want to loop. If you don't want to loop, it'll just take the last texture and keep applying it constantly over and over. With my method, however, set texture crop, it'll only run the code at all if you are not looping and the sprite number happens to be less than or equal to the total. Otherwise it doesn't do anything at all. So yeah, and this is the entirety of the code. That's it, done. So all it's doing is using texture matrix, which is the same method that everything in the system runs when it's moving a texture across the screen. It's just changing effectively the texture coordinates over time, and this is the same method. It's changing the texture coordinates over time and also changing the scale. So the width and the height according to how many sprites across and down you've got, columns and rows, and that's it. Sets the material. Yeah, so it's very simple. So that's just getting the information. That's pretty standard stuff, and that just applies it. So yeah, really simple code. extremely fast. As good as Dinko's, fast as Nico's method. Who knows? Could be faster. Hard to say. Haven't been able to test that. But yeah, extremely simple and extremely fast. And in C++, it's going to be better than anything done in JavaScript, whether it's a shader approach as an action or a non-shader approach as an action. The action approach is good if you only want to affect a single node. But this is designed to quickly work over hundreds of nodes in a very short space of time. That's why I've set it up this way. So it's extremely simple and extremely fast. And as you can see, it is starting from 1 and going through 16 on the smoke, because there's 4x4 on that particular one. And you can either use, like transparent add or transparent alpha. Pick one of the two. Transparent alpha will block everything that's behind it that's not alpha, whereas transparent add will blend with everything behind it and only add to the lighting effect, which is actually, for anything that glows has its own glow effect. That's probably better. Transparent add is actually quite good. So there's the meteorite. Looks good, doesn't it? It's using my texture crop API. So from the front of it, really no serious issues at all. Looks quite good all directions. Yeah, so that works really well. So yeah, if you want by far the easiest approach and the most versatile method, then you're going to want to use the API I made. I got a bit of help from Google AI, so I didn't do all the work, but I had to fix some of the mistakes Google made, which usually does make some mistakes. But yeah, so it works really well. Very happy with it. And I can individually manage each particle differently, one to the next, without there's no performance change between doing that at all. None at all. So works really well. As you can see, the meteorite transparent add, just turn lighting off. You don't some things that have their own glow effect, typically you either want it on dynamic lighting with its own emissive color, or oftentimes better to turn it off and use transparent add or transparent alpha, and it'll just have full color that way. It won't be reduced by the lighting, ambient lighting or anything else. Same with the glow effect. So transparent add textures by default will have a black background, because the background adds no color at all to the whatever's behind it. Whereas transparent alpha will have a transparent background, and it'll show in CopperCube as a white background instead. So that's the difference between the two. So for example, this one here, the meteorite, that has a transparent alpha, clear background, it shows as white. So yeah, I was playing with different methods. I was looking at using a particle system for a while, but never really particularly happy with it. Why? Because it's not really performant. It doesn't look that great anyway. It's okay if you've got small number of particles and it's moving slowly, but my meteorites are moving so fast that effectively what will happen is it's putting these dot effects everywhere. To get around that, you have to make a huge number of particles, and since I'm having hundreds up to 500 particles at a time, that's not performant at all, not very good at all. So I pretty much abandoned using the particle effects, even though it's not terrible. If you have enough particles, it's okay. But yeah, so I didn't end up going with that method. Stick to my standard sprite sheet effect. It works really well actually. If you have a good sprite sheet, it can look really good. Much better than particles, in my opinion. Yeah, so hopefully some negative comments received about this new API can get a little bit informed that actually it is very good and does what I say it says. Yeah, so it would be better if certain individuals would wait and comment after they know all the facts. That's usually the best approach. Anyway, so yeah, so I hope you like that. I'm sure it's going to help a lot of people, make life a lot easier with using sprite sheets now. Not having to cut them up in little tiny pieces. You have a single sprite sheet, and you just iterate over it in taking what you want. Works really well, actually. Pretty happy with it. Just one thing I want to mention, the vast majority of all my APIs and code fixes are driver agnostic. It means you can work with either DirectX or OpenGL, it doesn't really matter. That's the vast majority of, like 95% of the code updates. You can actually use it across the board. There's a few that only for DirectX, which is the materials. They're all DirectX 9. The post-processing shaders currently are all DirectX only as well. And there's a couple extras like global fog, that's DirectX only. Not much else. Virtually everything else. Okay, occlusion culling is actually DirectX as well. Yeah, but the vast majority of it is you can use it for either one. It doesn't matter. Just let you know. Okay, so this is my current version of Aurora. It's a different way of doing it, you know, like compared to what most people do whenever the Aurora effect. But I found this to be extremely performant. Has pretty much zero impact on performance, and it still looks pretty good. It's bright, it's clear. I'm pretty happy with it. And on top of that, I've got a method to changing out the look of it in terms of colors and shapes over time, which I'll be interested to know from you guys. Tell me how you think I did it, because I think you probably find that you might not be able to work it out. I'd be interested to know. $10 to anyone who can work out what node type system I used and how I changed the look of the colors over time. Yeah, $10. Anyone that wants it? Yeah, so over time you can see it's changing, all right, changing the colors and the position of the effect in the sky. I mean, don't really need to change it. Looks pretty good without needing to use a system to change how it looks. But anyway, that's how I've done it. And you can see it does considerably change over time. So let me know how you think I did that. Be interested to know if you can work it out. Yeah, so I'm pretty happy with that. I mean, there's other methods. There's the old standard approach. I could sort of imitate that as well. It's getting the right textures is a bit of a pain, actually, and the method I was using that was suited for it would have a lower resolution, lower quality effect, so it'd be blurred image in a sense, and I couldn't really fix that without using a really high resolution texture, and I didn't really want to do that. But this method, actually, the texture or textures method I used, the texture I used for this is it's not particularly high resolution at all, actually, but it looks good, isn't it? So that's nice. Yeah, I think it's an acceptable effect for an Aurora. Just a good sound effect, obviously, to go with it. I think it's pretty good. And also, I changed the ambient lighting according to the two colors in the Aurora. And I've got all the different colors Auroras. It automatically will start with a certain two colors, and then it'll change the ambient lighting accordingly. So yeah, it's not working at the moment here, but this is in my game. That's how it is. Yeah. Let me know how you think I did this. Get $10 if you get it right. All right, cool. So let me know what you think about this one. I think it looks pretty good. Good enough. Yeah. No worries. Hope you like that. Cheers.